Lecture video is about the nomenclature of transition metal complexes. So first we will know about the transition metal. So transition element, also known as transition metals, because all these elements are metals, are elements that have partially filled d orbitals. IUPAC defined transition metal as an element having d subshell that is partially filled with electron, or an element that has the ability to form stable cations with an incompletely filled d orbitals. So these are those elements or metal which has partially filled d orbitals. In periodic table, their position lie between the s and p block elements. So the d block elements are present between the s and p block elements. So the blue area that is represented by the d block elements. Metal complex or coordination compound. So what is mean by the metal complex and coordination compound? A metal complex are the molecules that form when transition metal ions are surrounded by the ligands, form a coordinate covalent bond. So the complex are the species that are formed when the central metal ion is surrounded by the ligand, that is the complex. So what are ligand? Ligand can small molecules, ions, or organic molecules. So these are the species that has the ability to donate the electron pair. So it is electron rich species, and the metal ion, it is the acceptor, electron acceptor species. So here it is metal ligand and it is represented in square bracket. So this is the metal ligand complex. This is the metal ligand complex ion, but that ion is present in the positive form. So the metal ligand complex is formed, but it is a cationic complex. Similarly, the metal ligand complex is formed, but it has negative charge, so we can say that it is anionic complex. So the neutral complex, that has no charge. Cationic complex has positive charge, and anionic complex has negative charge. Now what is coordination compound? This is the salt where either cation or the anion of the metal complexes. So the cation or anion, which mean that cation will be the complex or anion can be the complex. So this part, when this part is combined with some negative charge species, so it will form a salt. We know that the salt has two components, cation or anion. So in this case, in the first case, the cation is a complex and the anion is any negative charge species. In the second case, anion is complex and the cation may be the any charge species. So it is actually the salt that has cation or anion part, but the salt is that type of salt which has cation or anion part as complex. So this part that is present in the square bracket, that is complex, and that part is also the complex. Here the cation is complex and here the anion is complex. So when these complex ions combine with the alternate ions of the opposite charges, that will form the coordination compound. Types of ligand. There are three major types of ligand: anionic, neutral, and cationic. Anionic, as the name indicates, anionic ligands are the ones that have negative charge on them. There can either be molecular ions or atomic ions. Example of atomic ions are halide ion, oxide, and nitrite ion, while the molecular anion are composed of the more than one type of element. So it has hydroxide anion, cyanide, thiocyanide, nitrate, sulfate, acetate, etc. So it has atomic or molecular both species in anionic ligand. In case of neutral ligand have a lone pair of electron that can donate to the metal, so it has no charge, but these metal has lone pair of electron that can be donated to the central metal atom. The most common example are water, ammonia, carbonyl, nitrosyl, methylamine and triphenylphosphine. These are the most common examples of neutral ligand. In case of cationic ligand, it has positive charge. So the cationic ligand is a ligand that has positive charge. Nitrosonium ion and protonated hydrazine, these are the example of cationic ligands. So here is some examples of the ligand: anionic ligand, neutral ligand and cationic ligand, and how these are named. In case of anionic ligand, it will end with O, bromo, chloro, cyano, etc. In case of neutral ligand, their name will remain unchanged. So amine, carbonyl and aqua. Aqua is a special name for water. In case of cationic ligand, that will end with IUM, ammonium, nitrosylium, hydrazinium. So there are some terminology that is used in the nomenclature of coordination compound. So that iron, the species that is present in the square bracket in this sphere is known as complex. So actually this part is complex, and that is the secondary species. So the central metal atom is iron, and the species that is rich in electron is ligand. So the number of ligands that are attached to the central metal atom is known as coordination number. So here the 6 ligands are attached, so its number is 6. Coordination number is 6. Coordination sphere are the brackets in which the complex is placed. So all this area that is present in the square bracket is, or coordination sphere, it is known as complex. So this whole species is known as complex ion, and it is balanced by the counter ion. Either it will be positive charge or negative charge. Here the complex ion is anion, so it will be counter ion balanced by the positive charge ion. If the species that is present in the coordination sphere will cationic, then it will be balanced by the counter ion that will anionic. So here it is anionic species that is balanced by the counter ion that has cation. How to balance charge on complex? So we will take the example. There is a simple trick that we will easily balance the charge on complex by simple looking at the number or charge of the counter ion. We know that the species that are present in coordination sphere is actually the complex, and the counter ion is present outside the complex. So here we will look at the number and charge of the counter ion. From that number, from that charge, we will balance, or we will make this whole species as 0. So here the 4 potassium are present, and we know that 1 potassium has +1 charge. So there are 4 potassium, so we will put +4 over there. In case of complex, here 6 cyanides are present, and one cyanide has -1 charge, so we will get -6. In order to make it -4, we will put +2 over iron. So -6 and +2, it will result in -4. So -4 is actually the charge on the complex, and +4 is the charge of the counter ion. So -4 and +4 will result 0. Similarly, in case of cationic complex, the species that is present in coordination sphere is cation. So we will first look at the counter ion charge and number of the counter ion. So there is 1 chloride, and each chloride has -1. So it is clear that we will have +1 over coordination over this complex ion. So cyanide, there are 2 cyanide present, and each cyanide has -1. So -2 will be for 2 cyanide. Among these, if we look at this iron will be ferric, in ferric form in this case, because we will get +1 over this complex. So plus 3 for iron, plus 3 and minus 1 will result in plus 1, and plus 1 that is balanced by the counter ion minus 1, and we will get 0. There are rules for the nomenclature of coordination compounds. So first is the naming of the coordination compound or salt. Their order will be there, just like sodium chloride. Sodium chloride is not a coordination compound, but there is a specific rule for naming of salt, that cation will make the first, and it is followed by the anion. If we look at this structure here, it is the cationic part and the complex is anion. If we look at the second structure, it is the cation and the other one part is anion. Naming of the complex ion, we know that the species that is present in coordination sphere is actually the complex, whether it has positive or negative charge. So there are two major species that are present in the coordination sphere, that is ligand and metal ion. So the ligand will name as first, followed by the central metal ion. So the naming of the ligand will be in alphabetic order. If there are more than one ligand present, then it will be named in alphabetic order if their nature remain the same. If their nature is different, whether it is neutral, anionic or cationic, then the neutral ligand will be named as first, followed by the anionic, and at the end cationic ligand will be named. If there are monodentate ligand, monodentate of the same kind ligand, monodentate mean that it has only one point for the attachment with the central metal atom. Then for two ligand, for two monodentate, di is used, for three tri, and tetra for 4, and so on. If there is polydentate ligand, that the ligand is only one but it has many sides for the attachment. Then bis is for 2 sides of attachment, tris for 3 sides of attachment, tetrakis and pentakis are for 4 and 5 sides of attachment, etc. And the suffix, if the ligand is anionic, then O, it will end with O, bromo, chloro, that will be used. In case of neutral ligand name will remain unchanged, just like amine. And in case of positively charged ligand, it will end with IUM, hydrazinium. So it will end with IUM. So it is all about the ligand. If we look at the central metal ion, we will look at the oxidation number that is written in Roman numerals in parentheses. And in case of naming or suffix, if the complex is anionic, just like in this case, then the metal ion will end with the name of the metal ion with end with ATE, cobaltate, cuprate, ferrate, that metal. If it is cationic complex, in this case the metal name will remain unchanged. There is no change in the metal, copper 2, copper 1, iron, etc.